Safety spectacles. How you going, guys? Curtis from Cutting Edge Engineering. Today is part 2 of making our new H Link for an excavator. If you missed part 1, there'll be a link in the description below where we machined up the hollow bars and beveled the plates. So let's get into it.
Get into what?
So let's get into putting it together. So what we're going to do first, we're going to get the center plate and the side plates tacked together and all square and sitting level, and then we can start to attach the hollow bars.
Wait, you're grinding the table?
Yes.
Oh.
Take all the high spots off it, if there's any.
Will you eventually, like, grind your table away? No, I'm kidding.
So our side plates are 110mm tall. We need to bring the center plate of the hitch up to the center line of the side plates. I'll be using 35mm round bar in order to bring the plate up off the bench so everything falls in the center line of our side plates. Yep, that's fine. Really? Fucking dog. Don't start. Right, now that I've got that tacked together, I'm not going to fully weld them just yet. I am going to tack on the bosses, and then I will fully weld it as one component. It's like cooking. When you're cooking, do you do the veggies first, and then the meat, and then whatever else? Or
No,
do
you
do
time it all together.
Right.
Or you cook the meat and then try and cook stuff after and your meat gets cold.
Hate cold meat.
That's impressive. So then what, you just roll that in? Or what?
Pretty much. So now we've got our plate set up in the center line of our end boss. I'm just going to measure it and square it up and make sure everything's sitting flat before I tack anything in place. Fucking my own shadow is fucking me up. Call me Peter Pan. Oh, fucking games with me. Now that we've got that end tacked on, I need to do the other end with the two bosses. Trying to hold two bosses that are round and aren't sitting parallel to each other can be quite difficult. And to get everything in alignment, I'm going to be using the table off our old V20 Mosaic because it is a machine surface and round things will sit nicely in the T-slots. I'm just going to use a spacer, a couple of washers, a threaded rod, and I can tie these things together in the correct position and orientation, and then I can fit them onto the H Link. So the critical things when setting up bosses for anything is having your spacing through the center correct. So I've measured the original H Link and I have machined up an old piece of tube to the right length. I can then put that in between the bosses, clamp it together, and know it's going to be right. The other important part is the grease holes. Don't mix up where they are. They need to be in alignment and on the right side. Although it sounds silly, you'd be surprised how many people along the line have actually done that and put a grease hole 180 degrees out from where the other one is. Fuck off, train. Right, now that we've got all of those in alignment, we can now set them up on the rest of the H Link.
What? Oh, it's close to each other.
Now that we've got our bosses set up and in alignment, we can set them up on the H Link. These bosses are a smaller diameter, so we will need to pack them up off the table in order to bring them up to the center height. That end needs to go that way just a little bit. Oh.
Where's your bigger one?
Righto, so we've got everything tacked, everything is in place and in alignment. What I need to do is I just need to put a couple of heavy stitches around the job on both sides so nothing can pull out of shape when I go to weld it. But before I do that, I need to change my welding lead. So the lead I'm running at the moment is the lead I use for doing cylinder rods. It's got a pipe nozzle on it. I'm going to change it out to a standard lead that has the heavy duty nozzle on it. So the wire I'm going to be using to weld out the H Link is Verticore 3XP. It is the same composition as the rest of the dual shield wires that we use, and the gas I'll be using is Argo Shield Heavy with 80% argon, 20% CO2. In my bald head. So like any component that is being welded together, it is very important that you move around the job when you are welding it. You don't want to sit in one area because it will twist and buckle, and the chances of straightening out something like this after it's twisted is pretty much zero. So that's why you will see me move around the job, turn it over, and even out the heat that I'm putting into the job. We are using a multi-positional wire, so you can do it overhead, vertical up, horizontal, whatever you like. But because I can place the job where I want it, I'm doing everything downhand. It is the most comfortable and it is the best way to get a really nice weld finish. Righto guys, so all the welding is now complete on the H Link. We put about 5 to 6 passes in each joint. This thing is extremely hot, so we're going to have to let this cool down for a couple of hours before we can set up the line borer.
What you got? Okay. You got your carrot. What you got? Yeah. Oh, quick, come here. Come on, there's ants.
Righto, now that the H Link has fully cooled down, we can measure up the bosses and show you how much they pull out of shape after the welding process is completed. So the big boss has pulled out of shape 0.13 of a mil, so I was expecting that, and the smaller boss, it pulled out of shape 0.1 of a mil. Material can do weird things when you weld it. If one of those bosses was to pull too far out of shape, I might have to then bore weld that and re-bore it to size in order to bring it back into alignment. So by leaving 2 mil of material in there, I've allowed enough room for error that I can now bore this to size. But before I can set up the line borer, I need to get out the spacing sleeve that I use to hold the two bosses at the correct distance apart. So to set up my boring bar, I'm going to be using my shop-made centering cones. Even though the bores aren't exactly round, the centering cones will still find the center of the bore. So I've got the boring bar and the bearing blocks set up on the bottom of the H Link. What I'm going to do now is I'm going to set up the front position. I'm not going to weld the bearing blocks on yet because I need to make sure everything is running parallel, in alignment, and is true. So when this goes back together on the machine, there is no interference with pins because something is out of alignment. So to do that, I'll be using the keyways that are already in the boring bars. So I can butt a ruler up to the keyway and then measure across the job and make sure it matches up on the other end. If it doesn't, I can then make adjustments in order to bring them into alignment. Once I've got that done, I'll put a level across the length of the bar to make sure it is sitting true. and I'll also put a level across the two boring bars to make sure they're not twisted. So I don't need to make any adjustments to the boring bars. I can leave everything exactly the way it is. It is running dead parallel and everything is level. This is why it is so important when you are fabricating parts like this that you have a clean work surface, you have the right amount of shim material. Take your time so you don't end up with issues when you go to finish off the job.
Oh yeah? Oh, it's so little.
Take out exactly a mil. So I've got our first side bored, we've got the edges chamfered. Right, so we've got our first side bored. Fuck up, man. So we've got our force. Are you laughing at me?
I'm not.
Right. So we've got our first side bored to spec. We've chamfered the edges. I'm going to disassemble the line borer, spin the H link around, reset up the line borer and bore the other side. So because I can't run the boring bar all the way through this end because there is a stop shoulder in there for the bushes, I'm going to have to bore one side up to the stop shoulder, reset the tool on the other side of the H link and bore back toward the line borer. Now that we've got all the boring done, we can grind this up so it's ready for paint. So anywhere I've attached a bearing block to, we'll flatten down all of the welds and just do a general once over so it's ready to be painted. So the abrasives I'm going to be using to clean this up, these are a Sea of Bite. They're an 80 grit. They're just really good for cleaning up plate and welds. I'll also be using a 60 grit flapper wheel, and that's just to get around the corners, just to tidy things up. And the reason I'm using the needle scaler, it's just to remove any of the weld spatter that is stuck in the corners where I can't reach it with a grinder. To clean up the bores, I'm using a 60 grit internal flapper wheel. So there's one more thing I need to do before I can fit the bushes. I need to weld on this little shroud that I've machined up around the grease nipple to protect it from damage. Right, now that that's done, we can fit the bushes. So the bushes we're going to be using, they are aftermarket, but they are the standard size that the original H link came with. So when the customer needs to change these out, he can either order genuine or aftermarket parts and they're going to fit. So I'm going to be using liquid nitrogen in order to fit the bushes. We are going to start with the smaller bosses. I am going to be putting the lip seals on the inside of the H link, and that is there to avoid the bushes falling all the way through. And then once the bushes are fitted, I'll then fit the wiper seal to the outside of the H link, and then we can move on to the other side. so you'll notice with liquid nitrogen, when I first put the bush into it, the liquid nitrogen starts to boil. Just before the bush reaches its coldest temperature, you get a vicious boil and it intensifies. That carries on for a couple of seconds and then the liquid nitrogen just goes dead still. That is when the bush is at its coldest and has shrunk as far as it's going to go. And then it's ready to be installed.
Ooh.
Oh, you fucking dog. Locked solid. Righto, so things don't always go exactly to plan. As I was installing one of the bushes, it stopped. So it's locked up, it's not going anywhere, and I can't get it out. I did attempt to fit the other side, and it's doing pretty much the same thing. It's grabbing as it's going in. So rather than tempt fate and damage a bush, I'm going to use the press to press them in. I prefer to use liquid nitrogen for installing bushes because it shrinks down the bush and it'll actually go down inside the hole. And then once it thaws out or once it heats back up, it expands and grabs inside the bore. Pressing them, you're pressing something that is oversized for the hole. So you can actually end up with issues with the bush grabbing inside the bore. Things gall up and you can lock up bushes. And with using a press, it does take quite a lot of time to set them up and roll them over, find the right tooling in order to press everything together. But it looks like I'm doing that anyway. This might go to bang.
Oh, no, no. So just terps.
Wax and grease remover.
Whoopsie.
Spill it all. You ready?
Yeah. Ooh,
Ready.
that is nice.
I know, I'm ready. Here we go.
Why don't they come with a built-in funnel thing?
Fucking
That?
plate, please. Yep. I'm not a painter. That's it.
Ah, sit. Sit, oi, sit. Oh, you want one of those? Sit. Spin around. Hey, hey. Sit. Spin around. Spin around. Good boy. All gone.
Righto guys, so our paint is all dry. I'm really happy with how it turned out. I didn't get any runs in it. So now what we need to do is get it on a pallet, get it back in the workshop so we can finish it off. Righto guys, so our H Link is completed. I'm really happy with how everything turned out. It looks fucking shit.
No, it doesn't. It looks good.
Righto guys, so our H-Link is now completed. I'm really happy with how everything turned out. For a couple of days work and some material, we're able to give our customer a brand new H-Link for about half the price of a genuine one. And in my opinion, a fabricated H-Link is a far better option than the cast ones that come on the machines. I have seen my fair share of these over the years, and the cast ones always tend to crack once everything starts to wear out. They do not like taking a twisting motion, and if things are worn out and they do get a twist, they tend to snap. I believe it is so hard to repair that material because it's designed not to be repaired. And another reason would be for manufacturing. It is far cheaper to cast a component like this and then machine it to size than it would be to fully fabricate each link for each machine. There are other machines out there that have similar components made from the exact same material. I've contacted the manufacturer to find out if they have a repair procedure available, and they have advised me and sent me information stating that component is not designed to be repaired, it is designed to be replaced. There are many other brands of machinery on the market that do run fabricated H-Links, and I've never seen a fabricated one snapped. The material does allow flexibility, so it doesn't go under the same sort of torsional pressure that a standard cast one will. Not only that, the fabricated links are easily repairable. So with all that said and done, this job's completed. Let's get it back to our customer. Thanks for watching.
Yeah.
Right, and in my opinion, a fabricated H-Link, I'm being conscious of everyone saying H. All right, oh fuck, how am I going to start this? So I'm not going to weld it, fuck, fuck me. It's not funny.
What is going on?
Because the cast, because fabricated, fuck. Where was I?
Fuck, I don't know.
So we are going to start with these. I'm just going to start again.
Okay.
Right.
You want me to hold the other end?
Yeah. I don't have 3 hands.
I don't think I'm strong enough. Dad? No? Air blower? Oh. On the ground?
It's fucking hot. I can feel the heat radiating off it.
No, just lay down.